Welcome back to the Digital Logic Design video sequence. This time we're going to talk about design methodology. This is another abstract overview concept, but it's a very important one when you are starting to design any kind of device, to consider which approach you are taking. When we're talking about high-level design approaches, one of the one is referred to as a top down design. What they are down design methodology. So what they're talking about here is you're given a responsibility to design some function. So you're giving an objective with a set of functions you have to implement. And you will start your design basically by thinking about what functions are given and try to build the best design you have without any consideration of what it is that is available for you to build on. So that's an admirable approach to things, but that indicates that you're working on a vacuum and you don't have any parts of your design already built and available that you could use. The other approach would be a bottoms-up approach, which is kind of and it's very simplified and it's rarely used, but it's just we want to talk about a bottoms-up design methodology as well. This is where we know that in our company, in our toolbox, whatever, we have a certain modules, module 1, module 2, and module 3 that is available to us, and we want to use this to build something. Now, this could be potent. I mean, on the face of it, it's kind of silly to just use what you have to build something, but a lot of times if you work for a company, they have certain technologies, certain patents, certain know-how that you then try to figure out how we could use these tools and parts and knowledge to build something useful. Majority of our designs though, and most of the times when we are designing, we are actually designing using a technique called Middleout, which if we Middleout design, if you really think about what that means, that basically means, okay, I'm going to look and understand what the objective is, what function is it that the market, my company, my manager, my investor, whoever is paying the bills is interested in, what function they're interested in. Then we're going to take a look at available capabilities and available modules and tools and skills, and then we're going to try to see how best can we bring both of these together to be able to accomplish our goals. So generally when we're talking about design, we really need to do a survey of what it is we are trying to accomplish and understand that. At the same time, we need to look at what our environment can provide, whether it's some part that I can buy can purchase it. Is this something that we already have in our toolbox, in our company or whatever, and use those to accomplish the goal. So in this particular case, then we will end up with three approaches. A top-down approach, it would be, for example, in this case would be when you're going into a very new field, there is nothing available that you could leverage, although that's very rare these days to get into a field that there's nothing you can leverage. And if that's the case, and it's absolutely that way, then top-down would work. If you're in an environment where you're given certain things and say, what's the best thing you can make out of it? This would be in a company that has a lot of resources. They're trying to monetize or make money of what they already have. How could you put it together so they would be more successful, bottoms up? But majority of the designs, majority of the work we do actually is built around this last approach, which is the Middleout Design. And that's typically how we look at the world. We do a look at what's available to us, what it is we are trying to accomplish, and try to see what is the happiest medium we can come up with, the most successful way to add value to this environment, and trying to leverage as much as we can by using what already exists and getting the objective or the set of functions that they need us to implemented. Now, modularization is a very big thing, kind of. It's related. It is related to the design, but it's still a different topic, and that has to do with as much as possible when we design devices, we want to design devices where they are standalone, where if I want to build something more complex, I can take these individual components, hook them up together, and build a larger one. At the extreme, you can think of this as sometimes called the Lego approach, because if you look at the Lego components, I can put them together in each way, and each Lego component is complete on its own. It's got a way to attach to something else, and something else can attach to it. So in our case would be our devices have clear ways for people to talk to it. Now, I think one of the best example of this is what is happening in programming and software, pure software communities, because of the level of complexity sometimes that comes, and level of flexibility that you have in software. You're simply sitting in front of a key and typing. It has been shown that some higher level of control and higher level of methodology would be very helpful. And one of the successful design methodologies that have come about in the software world is called object-oriented design. And the reason for its success, it has, if the designer was to follow object-oriented design, then they would by definition create modules. They even have very specific criteria that they apply to our object-oriented design. For example, you have to adhere to what they call encapsulation. And encapsulation, as the name implies, you kind of encapsulate your piece of code or your design such that nobody can mess with what's inside. So the internal of the designs are hidden from the user. Only the interface definition, how to input and output from, is given. This way they can put them together all they want, but they can't change what's inside. The other one that in modular design, and I think the reason I'm using object-oriented design here is because they have very well characterized it, is the idea of inheritance. And the idea behind inheritance really has to do with you can start with the object that someone else has built, a module that someone else has built, and then you can add your features on top of it. In other words, you don't have to rebuild what they built, but you have an opportunity to put their stuff inside your object without having to recreate it and add on everything you want on top of it. So that's this. Both of these these approaches is very useful both in hardware and software. And then the next one, maybe not as much for hardware, but definitely for software, is called polymorphism. And polymorphism really has to do with the idea that depending on what input you put in, your system may behave differently. So if I'm adding, let's say I'm build an adder, when I put numbers in it, 1 + 2, it adds them together. The same adder, if I put alphabet in it, A and B, it puts them next to each other and gave me AB. Okay, so that would be an example of polymorphism. Okay, the other one, and which is the foundation and the reason we do object in many ways, is the composition. So I should be able to take many objects, put them all together to make something that does more complex function based on all of these. Okay, so we've kind of been jumping around a little bit in this topic, and design is a very interesting one because design, even though we try to be methodical about how we approach it, there's a certain level of arts in it. One, we talked about this broad concept of how you go about doing your design, whether you consider what are the things you have available before you decide what approach you want to take, or not. So you'll have top-down design, bottoms-up design, and then middle-out design. And then I used here the object-oriented design, or OOD, which is a well understood software design technique, pretty well accepted to these days in a way of creating modularity. As much as you can create your design, whether it's a simple lab you're going to do in the classroom or a final project, if you could build each piece of your design, test it, make sure the inputs and outputs are understood before you go to the next one, you would have a much more successful design. Now, in simple design, that the real benefit doesn't come through, but if you have a very complex design, this will allow you to not get bogged down in each module, because you know each module is tested, works well, and then you can worry about the bigger and the more complex solution.